Okay, with the periodic table. With the periodic table, guys, sorry. Okay, I told you the other day how more or less, well, not more or less, specifically how the structure is in the periodic table. We're gonna have three kinds of elements: metals, metalloids, and non-metals. What elements are those? Well, the easy part, the easier way to memorize them is you memorize the metals, you memorize the metalloids. Okay, so memorizing just knowing the metals is going to be easier because you know the non-metals and the metalloids, so the rest of the elements are going to be the metals. That is the easy way to do it. Remember, in the metals are in the left in the periodic table, except hydrogen, which of course is a non-metal. Okay, and the periodic table is arranged by periods, which are the horizontal rows, and the groups or columns or families that are the vertical columns. Okay, so the name of elements are going to depend, or they come to us from various sources. um, and the symbols, of course, well, a symbol is an abbreviation of elements. Okay, so there are some rules for writing symbols of elements. That's why I write it incorrect to you if you write it in the incorrect way. For example, symbols have either one or two letters, no more than two letters. If one letter is used, it's always going to be capital letter. If two letters are used, only the first one is a capital letter. Okay? So, writing a calcium like this is going to be incorrect because only the first letter is a capital letter. The second one is lowercase. Okay? So that is something that you need to know about the symbols of elements. And this is pretty much interesting information about where these elements or how these elements are named. Yasser, are you there? I don't see you. Okay. Maria Jose, are you there? Okay. It's funny. Kelly, are you? Yes. It's funny the way you place your phone because I don't see you. So take a look at this. Naming elements. If you ever wonder where those names come from, they come from different sources. Okay, one of those is they are named for places. For example, americium. It's called because it was the first element that was created in America. Okay, berkelium it was created in Berkeley, California. Francium because of France, of course. Scandium because the Scandinavia region in Europe. Okay. Some other elements are named because of some planets. Okay, for example, helium for the sun, Helios. Okay, because there was the first place where helium was detected. Then uranium, of course, because of the planet Uranus, and plutonium because of the planet. Well, it says former planet Pluto. Okay. Elements are also named because of mythological characters, like thorium, for example, after Thor. Titanium because of the Titans. Okay. Vanadium after the Scandinavian goddess of beauty, Vandis. Vanadium is known as one of the most, if not the most, beautiful element. Vanadium. So the name becomes from the Scandinavian goddess Vandis. Okay, and vanadium compounds they're going to show different but beautiful colors. Now to show you this, let me share the screen to show you okay, this one. So we were talking about vanadium. Take a look. Vanadium is a metal. It's a transition metal that you can find in your periodic table in the place 23. It's between titanium and chromium. What you see over there is known as vanadium crystals. Crystallization is a chemical process that many metals undergo. And in that case, you can see some of them have a very standard shape, like for example a cube. This one right here, as you can see, it is a perfect cube. Also this one. These beautiful shapes is because of the crystallization that vanadium has. And the variety of colors, as you can see, it comes from blue, violet, green, yellow, green, okay? You can see a variety of colors. And I don't know your opinion. Thumbs up if you think this element looks beautiful. Because I know that beauty is something that is subjective. Okay, so in my opinion, it is very beautiful because of the colors. But I don't know your opinion, so you might think that that's horrible. If you see me, that looks like a cockroach. I don't know what you think about. For me, that's beautiful. Okay, so thumbs up if you think it's beautiful. Nobody thinks. Okay. Okay, so we agree, right? At least the five of us agree that vanadium is a very beautiful element. Okay, I didn't want to be alone in this one. Thanks. Okay, we're six with Sadia. Nice one. So let's continue. So vanadium, it was named because of the Scandinavian goddess of beauty. Okay, why? Because the element is beautiful. According to the person that named it, it was beautiful, and I agree. And five more students agree. So yes, vanadium has its own beauty. Then we have tantalum and niobium that are because of the mythological Greek kings, okay? And then we have because of properties. Chlorine, for example, comes from the Greek chloros, that means green, because the element chlorine is a gas that is greenish yellow gas, okay? So most the color that you picture the most with chlorine is gonna be a green. So it comes from the chloros, that means green in Greek. Iodine is another element that I find it very interesting. I'm gonna show you why. Because iodine comes from the Greek iodos, that means violet. I have a question for you. What color is um, do you know what povidine is?
Yes.
Okay, what color is the povidine?
Like brown with orange or
Ah,
something.
like brown and orange. That is correct. But it says that okay, povidine is a compound that contains iodine. But it says that iodine means violet. So why is iodine violet? If what you see is brown, orange, brown, like none, okay? It's nothing alike, okay? Those colors are not even similar. So I want to show you a video where you're going to be able to see the reason why iodine means violet in Greek. But before I show you this, I want to tell you what sublimation is, because it's the video that you will see. Sublimation is, remember the physical state, the change of state. When you have vapor and vapor becomes liquid, okay? That is a change of state. And sometimes you heat some liquids and those liquids become vapor, which is called evaporation. But sometimes you are going to heat a solid and that solid will turn into gas. It's not going to become liquid before, it's going to become from solid to gas. That change of state is called sublimation. So I want that you guys see this video. Sublimation of iodine. At room temperature, iodine is black bluish color. Okay? Black bluish according to how the light hits. So take a look here. Oopsie, I didn't want to show you that. Okay, take a look here. You're going to hit this iodine, but I want you to see something. Okay, you can see these tiny spheres of iodine, they're going to be heated. This in the bottom, what you see is a plate, and that plate is is heated. Okay, it's going to hit whatever is there in the container. So when heated, solid iodine sublimates. Sublimation is that you see from spheres directly from solid to gas. And that's why iodine got its name from the Greek word iodos, that means purple, violet.
Means it's toxic. How you say is when you are with iodine, it's toxic for yourself.
Well, actually, iodine it is used I in medicine. It's used iodine as a povidine. Okay, it is used to get rid of bacteria. Okay, it is a great bacteria remover or killer. Okay, and it is used then also in health department in I how do we say for cancer treatment. Okay, iodine is used to treat cancer because it helps to contain or to reduce the size of, I don't know if they say melanomas or something like that, but the thing is that cancer is an abnormal increase of the cells that we have in our body. Okay, and iodine does exactly the opposite. It helps to reduce the size of those cells. So I'm not saying that you go and drink a full jar of povidine and that would be safe. No, but I'm telling you that it is the pure iodine is going to cause well, under medical supervision, I think it is safe to be used. And I'm telling you this because I know, well, a friend of mine, she had to go to El Salvador, okay, to get for cancer treatment. And the first stage of the treatment involved the use of iodine caplets. So it has a medical use, but of course it's always under supervision and always it has to be controlled because all the medicines that we take, they are not pure elements. I mean, well, here I don't have any. Oh yes, here I have something. So let me show you. Well, I cannot show you this. But for example, this formula, it says, this formula contains Betamethasone, 0.05 grams. Okay. What I'm telling you is that medicine contains several elements, but the amounts are important because if you exceed uh, those amounts by just a little bit, it could be toxic. So even though if iodine can be used to treat cancer, if you exceed the amount that is suggested, then it's going to be toxic. Doesn't matter how good it is to treat cancer, it's going to be toxic. So it is always going to depend and it's always going to be related to for you to be under medical supervision. Okay, that's gonna be my answer. Sorry for not saying yes or no directly. There are many things to consider, but that's what I wanted to show you. Going back to the topic, the sublimation in iodine, the sublimation that you see here, beautiful. Okay, it's beautiful. It's purple. But then what happens? They want to cool it down by using ice. Okay, so that iodine vapor is going to become solid, but in the form of a crystal. When this occurs, take a look. In the bottom we have the hot plate. Then in the center of the flask, you have all this iodine vapor. And because it's vapor, vapor rises. And when it reaches the ice, this ice is going to lower the temperature, turning the vapor into crystals. That what you see over there are iodine crystals. And you see that the color is nothing alike. It's like black bluish color like it was initially. But now it's shiny because those are crystals. But I wanted to show you why. I mean, why the name? Why iodine? Why iodose means violet? It has to do with the physical characteristic of iodine. Then other elements are named because other properties, like argon, for example, it comes from the Greek argos, that means lazy. Where do you find argon in the periodic table? Where is argon in the periodic table? In what group?
Non-metals.
In the group of the non-metals. And how do you call the last group where the argon is? How do you call that last group? Take a look. Argon is here. The 18 is in the group 18. In the last group is called the noble gases. They are called noble gases because they are unreactive gases. So they decided to call argon argos, meaning lazy, because argon is extremely unreactive gas. So they want to like to have a chemical reaction, but nothing occurs. So they say, what a gas. So lazy. Oh my god. So we're gonna call it argos. That's why. And cobalt, it comes from the Greek cobalt, that means goblin or evil spirit. Because back in those days, these cobalt miners often died suddenly and unexpectedly because they probably ingested arsenic. Because in the mines, in German mines, cobalt ore was reacted. Those ores, cobalt ores, included or had portions of arsenic, and arsenic is poisonous. Okay, if you ingest it by accident or because you wanted to, probably accident. The alkali metals are those metals that you can find in the first group in the periodic table. Except hydrogen, it includes the elements lithium, sodium, potassium, rubidium, cesium, and francium. They have plenty of characteristics, but one of the most important is that they are not easily found in nature as free elements. I mean, you cannot walk by and see, there is lithium over there. No, because they are very reactive. So it's never gonna be found as free elements because of the ability that they have to react. They are so reactive. And these reactive metals are obtained by reducing 1 plus ions. So elements in the group 1 that are called alkali, they produce 1 plus ions. Another important characteristic is that they need to be stored under kerosene or other hydrocarbon solvent. Could be kerosene or could be oil, okay? The reason is because they are so reactive that they can react with water vapor or oxygen in the air. So they don't want reactions to occur because the reaction of these elements is very violent. So to keep it unreactive, they have to store it in jars containing oils or kerosene. Okay, as you can see here in these pictures. It says that it consists of atoms with 1 electron in the outermost level. This is very important, okay? Because you know what this means. 1 electron in the outermost energy level. This is what we used to do in the electron configuration. So if you do the electron configuration of all of these elements, you will see that they have only 1 electron in the outermost level. Other characteristics, they form colorless ions, which has a 1 plus charge. That's why they are 1 plus ions. They form ionic compounds. You will see what ionic compound is in a few days. They form soluble bases. They are strong reducing agents. You're going to see this topic in 11th grade. And they consist of atoms that have low ionization energies. They are good heat and electrical conductors, like all the metals are. Okay, they are good at conducting heat and electricity. They are ductile, malleable, soft. How do you see they're soft? Take a look in the second picture. In this second picture, we're able to see sodium. This element in the second picture is sodium. Okay, we have sodium. And as you can see, this person is cutting it off with a knife. That is because they are soft enough to be cut with a knife. They have a silvery luster. You don't see it here because of the pictures, okay? But they have a silvery luster. And here, in sodium, for example, you see all this outer layer that it looks like brown. This happens because this sodium is already reacting, it's been oxidizing with the oxygen that is in air, okay? So all that outer part, it looks in a different color because it already started to react. As I told you already, they are highly reactive. So in this outer layer, what you see is the sodium that had already reacted with the air. And in the last picture, you have potassium. And this potassium, as you can see over there, is cut into smaller pieces. But still, it is contained in a... I don't know if that's plastic. I don't think it's plastic. In a glass container, but probably with another solvent. It could be kerosene or oil. That's something that I cannot determine by just seeing the picture. But the reason why it is stored like that is because of the reactivity that they have. And in the second group, those are the elements that you can find here in the periodic table. In the second group, next to the group that we had before, okay, next to potassium, francium, those elements. Now, I'm not going to go into those elements yet because I want to show you something. No way. Okay, yeah. I want to project this video so you're able to see the reaction of one of those elements with water. Okay. So basically, he explains that they are always too excited about the reaction of cesium and water, but at the same time, they are disappointed because the reaction lasts so little amounts of time. So they decided to modify the experiment in a way that they can capture all the reaction with a slow motion camera. But I don't have the time to project all the video. Bueno, I'm gonna leave it here.
Down here with white smoke trails because it's reacting with the water vapor in the air.
Okay. Good.
But what I think is exciting is that this whole...
Sorry, no, this is not cesium, this is rubidium. This is the second video that I projected with the other class. But basically the idea is the same, okay? Take a look what happens here in this part. Okay, they open the ampoule over there. It's because it's a glass, okay, that contains the rubidium metal in this case. In the moment that it breaks down, all these tiny portions of, in this case, rubidium, as you can see here, that is evidence, okay, this is evidence, okay. Right from the air, you can see that that rubidium is already reacting. All the smoke that you see over there is the chemical reaction that is occurring. And these tiny pieces of rubidium are causing that reaction. And this reaction is occurring there in the air before getting into the water. Once it touches the water, it's a lot more excited.
But what I think is exciting is that this whole trough starts flexing around, and it's really hard to bend. And even Brady, who's tougher than me, can't bend.
And that happens, the bending of the plastic is a really tough plastic, but it happens because of the increase in the temperature, because this is a chemical reaction where they release heat, okay, and that made it possible, okay, it made it possible to bend the plastic container. Anyway, I'm going to share with you all those videos so you can watch them again if you want. If not, doesn't matter, okay? It's up to you. You are the one that is going to be evaluated in the second or third week. So you better watch them. It's gonna help you a lot. Or not.